Welcome back to Math 103. This is video number 9 on growth and finance. Let's look at some examples of using the compound interest formula. One such example has to do with deciding how much to invest, that is, how much to put away into a savings account. For example, you have in mind that sometime in the future you want to buy a car, and you have an idea of how much you'll need to have saved up by the time you go to buy the car. So the question is, how much do you need to put away now? For example, suppose that you need to have $5,000 accumulated, specifically 4 years from now. That's when you intend to make a $5,000 purchase. So you invest now in an account which pays 2.5% annual compound interest. So how much do you need to invest now? The idea is to set up the compound interest formula. This relates 4 quantities to one another. First think, of these 4 quantities, which ones do you know the value of based on the given information, and which one are you looking to solve for? The way we reasoned out the formula, some amount of money, PV, the present value, is going to grow into some larger amount of money, FV. Now, we're given that that target for the future is $5,000, so FV is a quantity whose value is known. We're told that the interest rate at this bank is 2.5%. So the value of I is known. Remember, I always has to be in decimal form. That's really what we've been doing all along through this chapter. Finally, we're told that this money is going to sit in the bank for 4 years. The number of growths by 2.5% will be 4 growths by 2.5%. So let's not just apply this formula blindly, let's remember what it means. However much you invest is going to grow by a 1-year growth factor on 4 separate occasions. Once we've plugged in the known values for FV, I, and N, it's just a matter of computing and solving for the one unknown, PV. In order to solve here, we're going to have to compute the value of 1.025 to the 4th power equals 1.103813. It's always a good idea in these computations to carry some extra accuracy, a number of extra digits of information, rather than rounding off too soon. Finally, we divide both sides by 1.103813. That's the overall 4-year growth factor. We divide by it to isolate PV, to solve for PV. So it turns out the PV, the amount we initially need to invest, is $4,529.75. Not only is this an application of the compound interest formula, but it's also a realistic type of question. Realistic in the sense that you have a savings target that you want to reach by a certain point in time. The practical conclusion in this example is that if you allow your money to grow for only 4 years, and interest rates are low, 2.5% is low in the scheme of things, then it won't be able to grow very much. You won't have the opportunity to grow your money very much. If you really want to save up, you need to do some combination of starting sooner and finding a higher interest rate. Here's another example. Suppose that you need to borrow money now, and you can do so at 7% annual interest. Notice how the interest rate at which you borrow and the interest rate that you receive from the bank are very different, and the one that you pay when you borrow money is much higher. That's not a coincidence. So you decide to base the amount that you will borrow today on the amount that you expect to be able to pay back 10 years from now. This is actually not a bad idea at all, to look ahead to what you anticipate being able to pay back in the future. In other words, only borrowing now as much as you think you can afford to pay back in the future. Before going on to the next video, answer the following questions. If you expect to be able to repay $20,000 in 10 years' time, you think that's what you'll be able to afford in terms of how much you can repay, how much can you afford to borrow now? Second, the question is how much of what you're repaying, once you pay back that $20,000, how much of what you are repaying is interest? So a hint for the first question is, again, to set up the compound interest formula and consider which of the four quantities in this equation have known values based on the given information in the problem, and which value are you seeking?